This is the fourth example on margin of error and population proportions. So for these ones here, for the previous ones, we used the margin of error formula. As you can see with the last example we looked at, it wasn't the most accurate way of calculating it. So there is a more accurate way of calculating it using this formula here. Now this part of the formula is replaced the margin of error part. So what 1.96 means, that's going to be within 2 standard deviations of the mean. So 95% of the data, instead of using the 95% confidence interval, 95% of the data lies within 1.96 standard deviations of the mean. So that's where the minus 1.96 and plus 1.96 comes from. And then the formula itself here is the standard error of the proportion. Now this can be found in the log tables on page 34. So the previous page before the z-scores, you look at the bottom corner here, it says the standard error of the proportion. So instead of the margin of error, we're using the standard error of the proportion formula. And the way you'll know you actually have to use this formula, it says find the standard error here in the question itself. So the two different parts we have here, first of all, we have to actually calculate the standard error in the first part, and the second part then says in the 95% confidence interval. So this is a 95% confidence interval, since we know 95% of the data lies between minus 1.96 and 1.96. So working out each part first of all. It says find the standard error of the sample and distribution of the proportion at 95% confidence interval. First thing we need to find what is the actual sample proportion. It says in a survey carried out in a large city, 170 households out of a random number sampled, 250, owned at least one pet. So it's going to be 170 over 250, which we put in the calculator and is equal to 0.68. Now to calculate the actual standard error itself, we're going to use the sample proportion instead of the actual proportion itself, since we can't actually find that out. So to work out the standard error, we're going to write down our formula, which is the square root of p1 minus p all over n. So p is equal to 0.68, 1 minus 0.68, and that is all over n, which was 250. Put the full thing into the calculator, simplify it down, and it's equal to 0.029. So for the second part of the question, then what it asks us to find the 95% confidence interval of the proportion of households in the city who would own at least one pet. We can write down our confidence interval. Here's our formula here. Instead of writing the full thing out, it's going to be 0.68 minus 1.96 by 0.029, and then 0.68 plus 1.96 by 0.029. And we can put each side into the calculator. So the left hand side is going to be equal to 0.6232, and then the right hand side is going to be equal to 0.7368. So we know it's approximately around between 62% and 74%, approximately. Now you can see it's a much more accurate answer than the previous types of questions when we're using just the margin of error formula. So example 5, a random sample of 250 cars was surveyed, passing a certain junction, and 36 were found to have K registrations. So determine in a 95% confidence interval for the proportion of cars in that area that had a K registration. So the first thing we need to do for this question is to figure out what our sample proportion is. Sample proportion, 36 had a K registration out of 250 cars in total, so that is equal to 0.144. Now to find the 95% confidence interval, we also need to find out what the standard error is equal to. The standard error is equal to P by 1 minus P, and then all over N, which is 250. So we can work out what this part is equal to. So it's equal to 0.0222, And then from that, we can figure out what our confidence interval is. So our confidence interval was equal to the sample minus 1.96 by the standard error, and then sample proportion plus 1.96 by the standard error. So we have P in the middle, and it's going to be 0.100 on the left hand side and 0.1875 on the right hand side. So the 95% confidence interval is between 0.1 and 0.1875. Now, reading through the second part of the question, it says nationally it is known that 14% of cars have a K registration. Okay, so sample proportion in the previous one was this, but this is what it's known. What sample size of n is needed to be taken so that it 95% certain that an estimate of the proportion is within 2% of the population proportion. So what we need to do for this one here, remembering our standard deviation, our confidence interval for the previous one, it was going to be the sample proportion minus this error part and the population proportion plus the error part. Now here we don't know what p hat essentially is. We're just going to say p hat, the sample proportion and population proportion are very similar here. So it's going to be the sample proportion plus or minus 2% we're looking at here. So what that 2% is equal to, 2% is equal to the 1.96 by p, which is 0.14, by 1 minus p, which is minus 0.14, and that is all over n, which we're actually looking for. So what we're going to do then, we're going to try to solve this here for n. So the first thing we're going to do is divide by 1.6 on both sides. We're going to, so it's 0.14 by 0.86, and that is equal to 0.02 divided by 1.96. Then we need to square both sides to get rid of the square roots. So then it's 0.14 by 0.86 over n, and that is equal to all of this squared. And then in order to get rid of the n in the bottom, we're going to multiply by n on both sides, and then we're going to have to divide by this one here as well. So it's multiplying by n. So it's going to be 0.14 by 0.86 is equal to all of this squared by n, and then in order to get rid of it, we divide by that on both sides. So it's going to be 0.14 by 0.86 divided by 0.02 by 1.96 squared, and that is going to be equal to n. So n, when we put all that into the calculator, n is equal to 1156.32. So a sample size of 1157 would be needed. At the end.